Okay, children, welcome back to the online tutor. So today I'm going to discuss another important thing in our trigonometrics, right? So in trigonometrics we have several chapters, right? In these chapters, so trigonometric inverse functions, right? Inverse of the trigonometric function is very important, and in our A-level exam we will have a inverse function problem, right? So sometimes it in the structure paper, sometimes it in the essay paper, right? So first of all you have to understand what is this inverse function. So can you remember in your grade 11 you had a function logarithm? So logarithm function we all know that, no? So how to remove the log? We are using inverse of the log. So same thing for the sine, cos, tan. So we are going to put a inverse of the sine. It's like sine inverse x. So y equal cos theta. Then we can subject theta with cos inverse y. So likewise, we can use inverse function to remove that trigonometric part. Another example, z equal tan theta. So tan theta equal tan inverse z. So likewise, always the angle can be subject. In our logarithms, we use antilog, right, to remove the log. So likewise, always trigonometric inverse functions need to remove the uh, ratio part. So sine theta equal half mean theta equal sine inverse half. So sine inverse half mean 30, 5 over 6. Another example, like cos theta equal plus half. So theta is cos inverse 1 over 2, which is 60. So likewise, we can use our inverse function to uh, subject the angle. Right. So according to the our advanced level, so there are two types of inverse problems, trigonometric inverse problems. So the first problem type is proving identities, proving trigonometric inverse functions, right? So it's like identities. So second type, proving solving trigonometric inverse functions. So this is the main types that we are going to discuss today, and as an inverse function problem we will have these two types. Okay, according to the first one, prove the following, right? So I am taking an example like tan inverse 5 over 6 plus tan inverse 1 over 11 equal 45. So we have to prove this, right? So the normally we are starting from one side and we are proving it, no? So same thing, I'm going to start from the left hand side. This is alpha, this is beta. And actually tan inverse 5 over 6 is alpha mean tan alpha equal 5 over 6. So it's tan alpha equal 5 over 6. So tan beta is equal to 1 over 11 likewise. You know, alpha in the left hand side we have alpha plus beta, ne? So I'm taking tan alpha plus beta because we have the tan inverse tan alpha and tan beta, no? So I'm put tan alpha plus beta, though, so we can expand it like tan alpha plus tan beta over 1 minus tan alpha tan beta. So now we can substitute the values, pi over 6, 1 over 11 over 1 minus 5 over 6, 1 over 11. So likewise we can simplify it, right? Taking common denominator, 55 plus 6 over 11, sorry, 66, and the denominator also 66 minus 5 over 66. So we will have 1, right? It's 61 over 61. It's fine. It's 45 degrees, right? So tan inverse 1 mean 45, no? This is my RHS, and so left hand side and RHS are equal now. So we prove it, right? So this is the way of proving inverse functions. So now you can try this now. Please try it now. Alpha and beta, right? So like as the previous method. So first of all we have to define it now. Tan alpha and tan beta. And RHS, so we have alpha tan beta, then I'm going to select tan alpha plus beta, left hand side. So now I'm going to substitute the values. So it's root 3 minus 1, right? So likewise we can actually we can multiply by the conjugate of the denominator. So anyway we need 60 degree, no? So you know tan 60 mean root 3, right? So the final answer should be root 3. So for 2 root 3 over 2, right? So it's root 3. So tan alpha plus beta root 3 mean which is 60 degree. Tan inverse root 3, it's 60 degree. RHS. Okay, this is my third example. So cos inverse 4 over 5, cos inverse 12 over 13. So starting from left hand side, first of all you have to define it. cos alpha plus beta, which is cos alpha cos beta minus sin alpha sin beta. So then we can write sin alpha like 3 over 5, cos alpha 4 over 5. So in the beta, it's 30, 12 over 13 is the cos, right? So then other one will be 5 sin alpha sin beta 5 over 12, 13. So now you can substitute the values. It's beta 4 over 5. So this is 5 and 65. 48 minus 15. It's 33 over 65. So this is what we need now. Alpha plus beta equal cos inverse 33 over 65. So again it's tan alpha plus beta, right? So you will get 2 over 9. So here alpha plus beta like left hand side, but the right hand side our the answer is in the tan, no? Then you have to select tan alpha plus beta. 1 minus tan alpha tan beta. So we have to find tan alpha, right? So you should draw the triangle 4 over 5. So this is 3, right? 25, 16, 9. 9 means 3. 3 over 4. Tan beta is 3 over 5. So the ratio I select tan because of the right hand side. 27 over 20 into 20, 11. So it's 27 over 11. Alpha plus beta. Okay, this is a little bit different because tan inverse 2 over 3 equal half into tan inverse 2 over 5. We have only 2. So the I'm just arranging the left hand side into 2 tan inverse 2 over 3. So this is my alpha, right? So I'm going to start from, so alpha is 2 over 3, tan alpha equal 2 over 3. Then I'm going to start from left hand side with the 2 alpha. So tan 2 alpha. Tan 2 alpha is 2 tan alpha minus 1 over 1 minus tan squared alpha. So now you will get tan 2 alpha equal 2 alpha, then tan inverse 2 over 5. So alpha equal half tan inverse 2 over 5. 12 over 5. So this is my right hand side. Okay. So then we found the value of the right hand side with the starting from the left hand side. Okay, so now I am moving to the solving equation of the trigonometric inverse functions. Okay, this is my equation. So the inverse function equation solving mean we can use both left hand and right hand sides, right? So first of all you have to define tan inverse 2x. It's like alpha, tan alpha equal 2x, tan inverse 3x equal beta, tan beta is 3x. Tan alpha plus beta equal tan 45. In the difference between the inverse function solving equations and proving equations, we are going to start it from the previous case. We started from left hand side. So now the solving equation we can use the both side. So that is the difference between the solving equations and the proving equations. Tan alpha plus tan beta over 1 minus tan alpha tan beta equal 1. So solving equation, maybe you just need to find the values of x. Okay, this is 1 minus 9x squared, sorry 6x squared then we can simplify it. 6x squared plus 5x minus 1 equals 0. Solutions will be minus 3 and plus 2. No. Okay, the second example, tan inverse x plus 1 plus tan inverse x minus 1 equal tan inverse 4 over 7. So again you can start from alpha beta. So alpha plus beta equal 4 over 7 tan inverse. So alpha plus beta equal theta. So again we have to substitute the tan alpha tan theta, right? So actually this is easy lesson, right? So only thing is you just need to practice, and tan a plus b sin a plus b cos a plus b formula should be memorized. Again quadratic equation, 2x squared minus 4 x minus 4 plus 1. So it's 2x squared equal plus 1, then x squared equal plus or minus root 1. Sorry, yeah, x squared equal half, right? Okay, this is my next example. So we have tan inverse three partitions, right? Alpha, theta, beta. Alpha plus theta plus beta equal 90. So actually when you are putting tan for both sides, so tan 90 is obviously infinity, but it's difficult to expand three angles at a one time, right? So then what you can do, you can write alpha plus theta equal 90 minus beta. So then tan alpha plus theta equal cot beta. So likewise now you can simplify this easiest way to get the value of x. It's cot beta, no? Okay, these two questions you can try it. Right. So the 2 tan inverse x over 2 minus tan inverse x over 7 So the left hand side 2 alpha plus beta minus beta equal 945. Tan 2 alpha minus beta equal tan 45. So when you expand it, you will get 2 tan 2 alpha minus tan beta 1 plus tan 2 alpha tan beta equal 45 in 1. So separately you have to find the tan 2 alpha. Tan 2 alpha mean again 2 tan alpha over 1 minus tan squared alpha. No? When you substitute in values, you will get the quadratic equation. Okay, these are my answers for the x. Okay, so the next example, this is my next example. Please do it with me, right? So you can practice it. Actually, I think this video is enough to understand the all fundamentals in the trigonometric inverse functions. so we can factorize it. Okay, now I'm moving to the A-level paper corrections. 2018 A-level paper correction. It's 2 alpha plus beta equal 19. We have to show that, right? So you can start from left hand side. So separately you have to find tan 2 alpha and substitute the values. So here it's 3 over 4, right? 3 over 4, yeah, it's 1 minus 1, 0. So once denominator 0 means it's infinity. Infinity means tan 90. So it's proved. Okay, this is 2018 paper. Okay, now this is let's move to the 2019 yellow paper. So first of all, you have to simplify, solve the equation 2 tan inverse x plus tan inverse Actually, this hence part is little bit different. it's 2 alpha plus beta equal 90, no? So then 2 alpha equal 90 minus beta. Tan 2 alpha equal cot beta. Tan 2 alpha mean 2 equal cot beta. Then tan 2 alpha mean 2 tan alpha over 1 minus tan squared alpha. So you can simplify, substitute the values. So then the value of x, solution of the x will come. So this is the quadratic equation. So minus 3 can be written with plus 3 into minus 1. So it's simplified. So easy to factorize. Okay, I select only 1 over 3 and I'm going to substitute that 1 over 3 to the x. Then 2 tan inverse 1 over 3 equal tan inverse 4 over 3 equal 90. So then it's 2 tan inverse 1 over 3 equal 5 over 4 minus 1 over 2 tan inverse 4 over 3. Then tan can be, then 1 over 3 equal tan this whole thing. I assume that as alpha. So I'm going to draw the triangle with the tan alpha is 1 over 3, and the hypotenuse will be root 10. Cos alpha equal root 3 over root 10. So alpha means this whole thing, right? So it's proved that finally. Right. So this is the final answer. Okay, children, this is the end of the trigonometric inverse functions, right? So hope you will get idea about the trigonometric inverse functions. So thank you very much for participating and have a nice day. Don't forget to subscribe my YouTube channel.